Hello and welcome back to the next Physical Sciences 3 lecture. So we have elastic energy here up the top, and we're going to quickly talk about that before talking about the conservation of energy. So a key concept is that energy can be stored. Energy can be stored in materials by stretching or deforming them. So this rubber band here has been stretched, and so someone has converted chemical energy from their body to stretching the elastic band. And if you've done this before and you've let an electric band go, it might shoot off in this direction, and we can say that the energy stored in the band has transformed to kinetic. Okay, when the rubber band has moved, when the rubber band is moving. It can be converted to other forms of energy like sound or heat energy as well. So here it is. Think of flicking a rubber band. Stretching the rubber band requires energy in the form of a force applied, over a distance. So we've applied a force in this direction over some distance. If this force is released, so if you let it go, the rubber band will snap back, releasing the stored energy, which will in turn be converted to another form of energy, or sound or heat. Another example is the energy changes occurring bouncing on a trampoline. So when you bounce on a trampoline, energy is stored in springs. And it releases the person, is transformed into kinetic energy. Kinetic energy when it sends the person in the air. So that's another example of transformers energy transfer. So someone's jumped on a trampoline, that potential energy that they had has gone into the springs, and then when the springs releases, it turns the energy back into kinetic energy and sends the person flying in the air. And that's a good lead into conservation of energy. Okay, so just like before, conservation means that if there's been a change has taken place, the energy before the change is the same as the energy after the change. Okay, so the total energy in the system. So basically, energy is never lost; it's only converted. Okay, so this is this word here, converted, into forms which we cannot easily use. Example: heat and sound are two examples of energy, and we kind of think of that as energy being lost, but really it's being converted. So in a car collision, for example, considerable energy is used to deform the cars, and this generates a lot of heat and sound which can't be used. Mechanical energy, that is useful energy, so we can think of that as useful energy, is kinetic and potential energy. Okay, a perfectly elastic, so this is that word again, elastic collision is defined as one in which there is no loss of kinetic energy during the collision. Okay, so if there's no loss of kinetic energy, then that is an elastic collision. An inelastic collision, not elastic, collision is one in which part of the kinetic energy is changed to some other form of energy during a collision. Okay, objects in elastic collisions always spring back to their original shape. All collisions except on a subatomic scale lose some mechanical energy, but we can approximate an elastic collision with little energy loss. For example, Newton's cradle, billiard balls, other ones. A roller coaster approximates an elastic interaction between the cart and the earth. Okay, that's if we ignore friction. Okay, and if we ignore friction, we have conservation of mechanical energy here. So that means that the kinetic energy plus the initial potential energy, so the kinetic energy plus the potential energy is equal to the kinetic energy and the potential energy at the end. So the initial kinetic energy plus potential energy equals the final kinetic energy plus a potential energy. So thus, in a closed system with no friction, the mechanical energy is conserved. And I have an example of it here. So if we have a ball rolling along here, then up here the potential is high, and then we could, if we know what the height difference is between these points, we could work out how much potential energy it has, and then when it gets to its lowest point, all the potential energy is converted into kinetic energy, and then the kinetic energy returns to potential energy when it's up here. Okay, and as it slows down. Alright, and we'll do some examples in the next lecture.